one version of special limits. We're gonna discover the rule for how to do this, but there are two special limits that show up relatively frequently, and you're gonna think, why would these show up? And I really can't tell you why they show up until we get to the next chapter. What do you mean, these things? Trig functions?
Yeah. You can't get rid of them, can you?
No, they're never going away. Trig functions aren't going away. And I'm about to do easy natural logs, too. They aren't going away either.
Oh, yeah, those are on the journal.
Okay. So, in this instance, though, I mean, sine of x over x. Why would that be anything special? Why would we see this frequently? Like I said, can't really tell you that until we're ready to do the next chapter. But, okay, if I try to sub the number into that, what am I going to get?
0 to 0.
I'm going to get 0 over 0. Yeah. But this is not something I'm going to factor or do a conjugate of. So,
Are you going to do your special, like, sign or something?
well, this is just one of those special situations, and I am going to let the calculator prove this one to you, because it's easier for me. Can I kill that? Oh, let's just do this. Okay. I'm going to graph, and I'm going to ask it to graph sine of x. I'm hitting the trig button, which then lets me choose sine of x all over x. Okay, we were trying to figure out the limit of this baby as it approaches 0. What are you expecting to see based on your knowledge of sine, the graph of sine?
I'm expecting a hallway.
Are you expecting a hallway? Some said you're expecting some kind of a wave.
Maybe it's the hallway, wavy hallway. Yeah.
A wavy hallway. Okay. Well,
That's no fun. So
okay.
it's a weird wave.
It's a weird wave. And actually, this lower wave out here on the edges, that just continues forever. But it does this one extra bump right in the middle. So what is the limit as your x coordinate is going towards 0? What's your y coordinate going to?
1.
It's going to 1. Yeah. So this particular function, it's unusual, it's kind of weird, but it always has a value of 1. Now, what I want to show you...
What you want asking for on the journal is when evaluating limits involving function for the...
No, that's the natural log. That's not this. That's coming in a moment. Okay, I'm going to bop back there because I want to show you another strange and interesting fact of this particular graph. Okay, and by the way, you might notice I can't get back to my line where I typed in the function. How do I get back down there so I can mess with the equation I typed? You can try arrowing down here with the touch pad and it might show up. Fast way is, if you ever want to get down to that equation line, hit tab. Okay, notice it popped me onto F3. It always pops you onto an empty line. I typed on F2, so I'm going up 1 to get to F2. What I want to do is prove a point to you. Well, let me just click in there, yeah. Okay. What if I made this 5x over 5x? Do you think it changes the graph?
No.
Well, according to this, normally the 5x should change the period. You put a number in on x, you should get
You told
faster
us
waves.
it doesn't change. Well, would you? Whoa. That's a big error. He lied. He said it didn't change.
Did the limit change as you approach 0?
No, limit didn't change.
As you're approaching 0, it's always going toward 1. Doesn't matter what, it's going to change the rest of this weird thing happening, but that particular limit, if you're approaching 0, it always ends up approaching 1, regardless of what numbers you put in there. It's just a freaky kind of thing. Okay, so this, I'm actually going to write this as nx, so meaning it could be any number on it. As long as it's the same number, top and bottom, you will always get 1. Okay, this other limit also always has a value. If you're approaching 0 again, you'll always get the same value. Anybody want to guess?
-1.
You are correct on that assumption. 0 and 1 are always good guesses. Oh shoot, it's not gonna let me keep that then. Okay. Do you want me to leave the 5x in there or make it a plain x?
Make it a plain X.
Plain x, okay. This is also just as true as the last one. It doesn't matter what number I put on x. It always does the same. Rat. Fine, Control Z. Do y'all know that have I told you that your keyboard shortcuts, if you know Control Z does undo on a computer, it does Control Z does undo on here too. Ooh, that was kind of sweet. I need you to go. I just need to take it. This is much easier with fingers. Now I went too far again. Fine, just go down. We'll just start a new one, then I don't have to mess with it. 1 minus cosine trig cosine x over x. Ignore the shading. Get that out of the way. So, as you approach 0 on this one, what y coordinate is it going to? Look at the wave, not the line. As I approach 0, I'm always going toward 0. Yeah, it's always toward 0. Wouldn't matter what, and once again, whatever numbers I put on x, it'll do the same thing. It's always going to go toward 0. So yes, your guess that 1 and 0 are always good guesses, or that's a pretty good statement. That one always goes to 0. It's just fact. So, what can I ask you to do with more problems then? What is there else we can do to these things? So, suppose I gave you the sine of 5x over plane x.
It's still going to equal 1. No, it's going to equal 5.
Is it going to equal 1?
No.
Because I said that you have to have the same number, the same coefficient on both x's. Okay. So what we're going to do is we're going to pull a sneaky trick here. If this is sine of 5x, I can't change what's inside the trig function. You can never change what's inside a trig function. So if that's a 5x, what do I need on the bottom? I need a 5. Okay, so I would like to take the bottom times 5. But I can't just take the bottom times 5. That's not allowed. But I can take top times 5 too, can't I? Okay, now, does that 5 multiply inside the trig function and make a 25? No, it stays out front. And here's a cool little sidelight of limits that we haven't talked about yet. If you have a constant number that you're just multiplying by, you can choose, since it's a constant number, you can choose to yank it out front in front of your limit. So I'm taking that 5 on top out front. And I'm choosing to leave on the inside then 5x over 5x. So now I have this 5 out front times, what's the value of that whole limit? 1. I get 5. Okay. This is a hint to number 11 on your assignment. I'm only going to start it. Nope, you have no book assignment. What if I give you something funky like that?
Hey, it's not number 11. It's not number 11.
It's not number 11? Why do I have number 11 written on here?
It's 12.
Oh, maybe I redid my worksheet since I printed these notes. Okay, it's 12. It's on there. Okay, well, is that even anything like this special situation?
Nope.
I mean, other than it's got sine of some number x, what do I do? Well, I want to make it look like this because I want to be able to apply this limit.
Yep.
Okay, so, but since I have a sine of 6x, I would need sine of 6x to be over what? I need to be over 6x. Okay, Well, first of all, I need to just get over an x, then we'll worry about 6. This is the sneaky part. Is it legal to take the top and bottom of a fraction by the same quantity? So if I took them both times 1 over x, that would be legal?
Yep.
Mm-hmm. And so then I could say that I have the sine of 6x over x and the sine of 8x over x. I am just mathematically manipulating. It is. And so then you tell me what's going to, that's still not going to use this limit because I need sine of 6x over 6x. How did I do it here?
Well, you multiply top one.
I told it by, so what can I do over here? Because I can do that as 6 over 6, can I?
Yep.
But I would take this one as 8 over 8.
Wow. And that's going to equal.
And then you choose which numbers would you rather pull out front and which numbers would you rather leave inside to form this nice little expression.
Pull 8 and 6 out? The top 8 and 6 out? Alright.
Yeah.
6 over 8.
So you'll end up with 6 over 8 out front, yes.
That's crazy.
Yes, it is. But it's good for you. Yep. Yeah. I'm going to let you all finish it, but that's the stretch. Okay, you will see the sine one way more than you'll see the cosine one. The cosine one is boring. Because I won't tell you 100% of the time, probably 98% of the time, the answer to this one is going to be 0. There would be very rare instances where you can get it to come out something else. So that one doesn't have much pizzazz and excitement. However, you are not allowed to write, every time you see a 1 minus cosine of x over x with any other numbers in it, you're not allowed to just write 0 because that's a good guess. You would work it the same way, though. If I had given you one there and said, oh, golly gee, I have 1 minus the cosine of 16x over x, you still need it to do what? I need to be a 16x, I need a 16 on the bottom, so you would still times it by 16. You still work it the same way. You pull the 16 out front. Yeah, and but it'll get multiplied by 0, which is the problem, so you always get 0. But you can do that. Because I would be pulling the top 16 out front, leaving it as 1 minus cosine of 16x over 16x. But that's always 16 times 0, which is boring. So I'll tell you, I'm way more inclined to give you the sine one just because you can get an answer from 0. So that's one form of special limits you get. Form number 2 of special limits, and this is mostly you just knowing this. I'm going to bug you with these. There are 4 limits you have just got to know. Pure and simple, have to know these.
Where are these on the journal?
They'd be in the listing section, I would think, probably on the back. Okay, these 4 little limits are going to haunt you. And my best recommendation, you can just flat memorize them if you are that type, or if you think of what the graph looks like, it gives you the answer. So I'm going to ask you, what's the graph of e to the x look like? Exponential function.
Oh.
Yeah.
Yeah.
Got an asymptote right here.
Yep.
Crosses at 1, and it just goes shooting up. Okay, so if I'm asking you the limit as x goes toward positive infinity, your x coordinates go out to the right where your y coordinates going. It approaches positive infinity, yeah. But if you're doing an E and your x coordinates are going left, then you're following the asymptote and you're going to get 0. There's a pattern here I'll point out in a moment once we get natural log in. Now, shock me, surprise me. What's a natural log look like? Yeah, where's its asymptote?
0. X equals 0.
Y-axis. This one crossed at the point 0, 1. Where does the natural log cross?
0.
At 1, 0. So it comes up and goes out that way. Okay. So if I ask you what's as x approaches infinity, you're going right, it's going to get positive infinity. Now, why did I do 0? Why didn't I do negative infinity? Why can I not do this graph and have it head left toward negative infinity? It doesn't exist over here. It can't go past 0. So as far as to the left as we can go is 0. And you can only go at 0 from the right-hand side because there's only a right-hand side. And where are my y coordinates going? Negative infinity. Yes.
Oh, you're recording.
I am. Oh, thank you.
That's gonna be